Now dear student, we are going to discuss question number 1.28, and in this question we have three parts A, B and C. Clear? In the first part it is given to you a conductor capital A, as you are seeing in the screen. A conductor capital A with cavity as shown in a figure is given a charge capital Q. Fine. Show that the entire charge must appear on the outer surface of a conductor. Clear? So first situation is given to you like this. Let's suppose we have a conductor and we have a cavity inside this conductor, and now we are providing total charge Q on this conductor. Clear? Now we have to actually prove here that the entire charge is appearing on its surface. Clear? So now concentrate on a screen. Let's suppose actually I am drawing here a Gaussian surface. So let's suppose I am drawing here a Gaussian surface. This is very close to this cavity. Clear to you? Let's suppose this is Gaussian surface and it is very close to cavity. Now we know, we can see, if we talk about Gauss law, according to Gauss law we can see finite this should be equal to Q by epsilon naught. Yes or no? And we also know this is also equal to integration of E dot dA. Clear? Now we know inside a conductor we have electric field, this is 0. Clear? So when in the we can say in a cavity we have E equal to 0. Clear? So when E equal to 0 we have, from here you can say Q, this should be equal to 0. Now listen carefully, this Q is what? This Q is the net charge, this is present inside this cavity, it should be 0. Clear? Now you can see in this cavity at this time we do not have any charge. Clear? So we can say here we will not find any charge. So what will happen when we are providing charge Q? Then this charge will be distributed all over its surface. Clear? So like this we can prove here that if we are providing charge Q, and let's suppose this is positive charge. So when we are providing charge Q on a conductor, this total charge will actually distributed on its surface and there is no charge, this is present inside. Clear to everyone? So I think part number A is clear to you. Yes or no? Clear? Now let's suppose situation is changes. In the situation number B, it is given to you another conductor B with charge Q is inserted inside a cavity. Means now what we are doing, we are placing here a conductor, and let's suppose we are providing here a charge Q. Yes or no? And important part, we have this A conductor and the B conductor are isolated from each other. Yes or no? So now we have to find that actually we have to prove the total charge on the outside surface is capital Q plus small q. Clear? So now what we do? Again actually we will draw here first Gaussian surface. Clear? So concentrate. Let's suppose I am drawing this figure here again. Let's suppose this is a diagram. Let's suppose here we have a conductor, and let's suppose this is conductor inside which we have a cavity, and this is E. Let's suppose now we are placing a small charge Q. Let's suppose this is charge Q, and let's suppose B. A is B isolated. Clear? Now what I am doing? I am drawing here a Gaussian surface. So let's suppose I am drawing here a Gaussian surface. This is very near to this cavity. Clear? Let's suppose this is Gaussian surface. Now I can say definitely, because inside this Gaussian surface we have a charge, so definitely we will find here net electric field. Clear? So we can write like this: find net, this should be equal to Q by epsilon naught. This should be equal to integral of E dot dA. Yes or no? Now our objective here is to find that what is total charge that is present on the outer surface of conductor A. Clear? So actually we are providing total charge Q to this conductor A. Clear? But we know, if we talk about this Gaussian surface, inside which we can say we have a cavity. So in the cavity we can say there should be net electric field is to be 0. Yes or no? Whenever we find cavity inside a conductor, net electric field is 0. Clear? So actually we have already charge Q is present. It means if we want that electric field should be 0, at that time we have to introduce a charge minus Q here, so that the net charge inside the cavity becomes 0. Yes or no? It means we can say, let's suppose if I provided minus q charge on the inside surface of conductor A, then we can say net charge this is inside this Gaussian surface is 0. Yes or no? But we know if we are introducing minus q, definitely we have to add here plus q, so that the total charge on conductor A, it remains capital Q. Yes or no? So now we can see, like this we can prove the total charge on this is present on the outer surface of conductor A. This is capital Q plus Q when we place a conductor, or we can say when we place a charge small q inside a cavity. Clear to everyone? Yes or no? So this is all about part number B. Clear? Now we have part number C also. A sensitive instrument is to be shielded from strong electrostatic field in its environment. Suggest a possible way. So let's suppose we have a sensitive instrument and we want to prevent it. So what we can do? We can place that instrument within a hollow cavity. Yes or no? So let's suppose we have a conductor and inside that conductor we have a cavity. Clear? So if we place that instrument in that cavity, we know electric field in a cavity becomes 0. Yes or no? When electric field is 0, it means we can say now there will be no damage by external electric field on that instrument. Yes or no? So like this we can prevent any instrument from electrostatic field in environment. Clear to everyone? So this is all about this question.